So we can start. And a few words about our first speaker, Alvaro. Alvaro is a senior developer, software developer, and computer engineer with uh, 10 years of experience in IT industry and a passion for learning cutting-edge technologies. He has participated in more than 10 projects in cross-functional teams between 6 and 12 people with clients like PayPal, Ancestry, Salesforce, Mercedes-Benz, and Bank Colombia, just to name a few. And his interest in Elixir started in 2021, so he's been enjoying this programming language for 3 years. So, Alvaro, thank you for joining our meetup, and you can prepare your presentation.
Okay, thank you for that great introduction. Yeah, so let's get started for today's meeting. The idea for today is talk a little about tips and tricks on how to develop an app on OTP. The idea is to show some common mistakes to avoid in order to work to an OTP. And yeah, let's try to unveil some mysteries around OTP. But first things first, so who is this guy? I'm Alvaro. I'm a computer engineer from Uruguay. I work as a staff engineer at Whiteworks. Whiteworks is a Uruguayan-based company that works with React, Ruby, and Elixir, among other technologies. I've been making software for almost 10 years. I don't know if good or bad one, but software is still itself. My first encounter with functional programming was in Haskell at the university a couple of years ago. And in terms of my experience, I've been working with Java, Salesforce, a little of React, Java again, and then Elixir. So hopefully I will be investing my upcoming years in this great language. These are the topics that we are gonna discuss today. We are gonna start with a little of OTP. What is OTP? Then a little of processes in Elixir. After that, we are gonna talk a little about behavior because these two concepts are important to understand the next topics of OTP. And this is agent, task, and GenServer. So what is OTP? So OTP stands for Open Telecom Platform. Basically, OTP is a huge set of libraries that came from Beam. Beam is the virtual machine of Erlang, the one in which Elixir is running. So a little of history. So long story short, Elixir is built on top of Erlang. Erlang was the language developed by Ericsson, later known as Sony Ericsson. Yeah, that company that maybe some of us will remember for designing those mobile phones with fancy shapes in the year 2000. Well, that company. Um, the engineers in that moment want to find architecture that was reliable, and the idea of making that architecture is that they need to have a system that can be distributed, can be fault tolerant, and run in real time. So that is basically the idea of Sony Ericsson in that moment. So in OTP, we are going to find a lot of stuff, such as the Erlang compiler, databases, we have the framework, we have profiler, among other things. And the things that will be important for us today is that in OTP, we have agent, task, and GenServer available for use to us. Well, a little of processes in Elixir. Processes in Elixir are the basic building block. Uh, Processes allow us to build complex application. So, for example, the unit of concurrency in Elixir is the process. One thing that we need to take into account, we don't have to be confused between a Beam process and a OS process, because Beam process are much lighter than a OS process. Just to have an idea, a Beam process just take a microseconds in order to make the creation, and the footprints of memory is much less rather than a OS process. Another point to bring here is that processes are isolated from each other. And this is quite important because this means that a crash in one process doesn't mean that it will take down other processes because they share no memory. And our last point that is also important is that processes under the hood are mailboxes that are communicated through message sending. And one process can attend one message at a time. That is also an important concept to have in mind. Okay, a little of behavior. We can see, or we can have an idea about behavior in Elixir, um, having an idea of we have a way to make a separation between the generic part of a component from the specific part of a component. That's the main idea. For those who came from, let's say, a more object-oriented programming language, we can see behavior kind of an interface. I mean, it's not a real interface, but it's something similar. Um, Maybe a difference between a pure interface is that in the behaviors, for example, we can see some warnings when we miss function defined in the behavior. Probably in object-oriented programming, if we miss implementing some of the function of the interface, we're going to see errors, but in this case, it's just warning. And yeah, behavior is a core concept in Elixir because OTP modules use the concept of behaviors and callbacks. So that is why we invest this time trying to understand what is a behavior. Okay, here is a very, very simple example to understand a little better the concept of the behavior. So in the upper part, what we have is the behavior model. This is the generic part, and we have a function. In this case, we have a great function. This is a function that just receive an argument and return the same argument. The behavior module must have the annotation at callback to say, okay, this will be the function that our behavior will have, and then we need to provide an implementation for that behavior. So that's why we have a callback module. In that callback module, we need to annotate with the add behavior, making reference to the behavior module, and then give a specific functionality to that function. In this case, it's just a kind of a dummy function or the identity because it's just receiving an argument and returning that same argument. But this is an example that is quite good to understand that a behavior we have the generic part and specific part. Okay, let's see this example. This is a more interesting one. So let's say that we are building an application and our application needs to send different kind of messages. So we can build a behavior called notification sender. Obviously, we can or we need to annotate the function with the add callback. So in this case, we have a behavior with a function called send message. The one that will be received two params. The first is the recipient and then the message. And as the result, we can return the aram okay if all went well, or a tuple with error and the reason is something doesn't went well. So let's say that in some part of the application we need a email sender. Okay, we need to send message but through emails. So what we are going to do in this case, we are going to create a callback module. Again, we are going to use the add behavior to make reference to our behavior module, and then we need to provide a specific implementation for that function. In this case, we are receiving the email address and the message. We have some operations in the middle using the pipe, and then we are sending an email. But let's say that our application also needs to send a message, but in this case, we need to send a message to a mobile phone. Okay, no problem. Again, we create a new callback module. We annotate with the add behavior to the behavior module, the one that we give an implementation, and then again, we implement the send message. In this case, we receive the phone number, the message, and the logic in order to send the message. So what do we have here? We have a generic module, our behavior, and we have two specific implementation. So while the API, let's say, we can see the behavior like an API, the API is the same. We are providing two different implementation for that behavior. So that is another example that we can see or use when we deal with behavior. Okay. So that being said, let's go to our first topic for OTP, and this is the agent. Okay. So here we are, agent. So in Elixir, it is very useful to find a way to store state in our programs. And a way that we have in Elixir to achieve that is through agent. So agent is that long story short, an agent is a abstraction around state, is a process that provides with a very simple API in order to store and to get the state. So if we want to store the state, we can use agent.update. If we want to retrieve the state, we can use agent.get. And another feature about agent is that it's easy to control the life cycle, adding it under a supervisor. For those that doesn't know what is a supervisor, in short, a supervisor is a process that we have available in Elixir, and its main goal is to control the life cycle of a process. So we are going to have different strategies depending of what we want to achieve with that supervisor. Okay, I will share my screen so we can see some examples about agent. So yeah, here we are. This is a very basic project in Elixir. No Ecto, no Phoenix, just a regular project. We are going to have a supervisor, so we can add children to our supervisor. And let's see the first example. Imagine that we are building a payment application, an application that enables us to send money between users. So in some moment, what we wanna achieve is that we wanna place or a process in order to store all the currencies that will be available um, in our application. So a way that we can do that is through an agent. So here we can see that we are using the use agent. What is doing this use agent for us is wrapping the functionality that is available on an agent inside our model. So in other words, what we are doing with the use agent, we are having the behavior of an agent in our current model. That is why we invest some time try to understand what is an agent. So the first thing that we are gonna use here is the start link. The start link is a function that we use to spawn a new project, a new processor. In this case, is an agent. When we use the start link, we need to provide the initial state. Here we start. We are gonna just returning an empty list as the state. And we give a name to the process. This is the default name, the same name of the model. After that, we are going to have two functions, add element and get elements. The add element function, what is going to do is just will append a new element to the current state. Basically, what we are going to do is add a new currency to our system. And then we have the get element, the one that will be returning all the states. Okay? That is basically what is doing this. So let's give this a try. We need to first add this agent under the supervisor. So here as a children, we are our agent. And yeah, let's run this. Okay, so in order to use this, you can just get the name and let's see if this has anything. Okay, this is empty, and we can also add information. Let's say that we are going to add the USD as a currency, and right after, if we grab the element, we can see that here we have the state. In this case, it's just a list with one element. So let's see some possible situations that can happen when we work with agent. So let's say that instead of start our agent with an empty state, we need to, for example, retrieve all the currencies that are stored in a file from this or in a database, or let's say that we need to make an external API call. So instead of giving an empty list, we are going to do something special. In this case, it's a operation that takes 4 seconds. Okay, so let's see what happens if we start our agent with that heavy operation. Okay, what is happening here is that we are blocking our client. We are blocking our client because the Starlink is doing something very expensive, so the client cannot continue its flow after this return the control to the client. So this is something that we need to take into account. The main goal of an agent is just a wrapper around state. We need to avoid adding some complex functionality when the agent is making the initialization. Maybe a possible workaround for this is to have, this is a spoiler alert, we can have a task making that heavy operation, and after the task finish, we can update the state of the agent, and in that way, we avoid blocking the client, okay? So that is something that we need to take into account. And the same goes to the other operation of the agent. So let's say in the get elements, instead of returning the state, we are gonna also do something expensive. In this case, this will just return these currencies. So here, if we recompile and we just give a try to the agent, let's go here with the module and let's try to see what happened after we get the elements. Okay, so in this case, we are also following a bad pattern. We are blocking the client because one of the function of the agent is taking too long in order to make that process. So again, we need to make an agent as light as possible. One workaround for this maybe can be to make that heavy operation outside of the agent. This is, we first fetch the state of the agent and we work outside of the agent. But pay attention to this because, for example, if we are making some operation outside of the agent after getting the state of the agent, and in the meantime, another process modify the agent, modify the state, probably we are gonna have race condition because we are returning an outdated version of the agent. So pay attention to that also. And yeah, that is an example of an agent. So let's continue with the other slides. Okay, let's see task. Task is another OTP that we have to use in Elixir. The idea of a task is just execute one particular action through its time. Most of the time, we don't need to communicate with other processes, so this is normally to see a task to run in an isolated way, let's say. And the common use case for a task is to convert sequential code into concurrent code. So in short, that is the functionality that we are gonna find in a task. So I will share the screen again to see some examples about task. Okay, so here we'll have an example of how to convert sequential code into a concurrent code, okay? This is a simple module. The goal of this module is to send emails to each recipient. In this case, we have 3 email addresses. So right after we have that email addresses, we are gonna execute the notify all. The notify all, which will gonna iterate through the list of the emails and create a task for every email to send that email. So in this case, we are not wrapping the task in a module. We're just invoking a function that is available on the task, and this is the start. In this case, we are just providing a function, the one that will be executed in every task. So for example, if you wanna give this a try, we can just go here to the task, and we just send notification. So in this case, we are getting a task for send an email to this, and to this. So this is just a very basic example of how we can convert sequential code into concurrent code using the task. Okay, and let's see another example of a task. Let's say that we continue building this payment application. Let's say that we continue have the need to fetch the currencies and store the currencies in some place. So in this case, we are going to have a task. In this case, we are using the use task because we are injecting the functionality of a task in our module. That is why we are using the use task. And again, here we have the start link in order to spawn this process. What we are doing here is that right after the task is starting, we are going to execute this run function. So this run function will make two things. The first is we are going to fetch the currencies from the database. Here we are just returning a list, but imagine that this is going to a database, and right after we are storing those currencies in the previously created agent. So we are gonna reuse our agent. Okay, so this is the main goal for this task. So for example, we can go here and run the task. So we can hit run. In this case, we are not providing any param, so we just pass an empty list, and we can see that here we are getting the currencies from the database and storing the currencies in agent. So if we go back to our agent, the one that we created before, and if we execute a get element, we can see that the currencies are stored in our agent. Another thing that we want to do is, okay, let's say that I don't want to manually execute this task. So what I want is that in the application startup, I want to have up and running all the available currencies of my application. So that is quite easy to do. We just need to go here and add the task as a children to the supervisor. And if we give this a try, we can see that this is already getting the currencies from the database and storing the currencies in an agent. So in this case, we have a nice use case in order to use an agent and a task in a combined way. So that is two possible use cases for the task module. And let's continue to our last OTP of today, and this is the GenServer. So GenServer stands for generic server. So what you are going to have with a GenServer is the server implementation of a client-server relationship. Um, it's similar to the agent, but probably we need to migrate from agent to server when we need to make some complex logic, some complex computation, rather than having only a state in which we can store and retrieve the state. So GenServer also provides a wide set of callbacks that we have available to implement. We can execute synchronous code, among other things. And also we can receive a send message. This is quite similar like the agent. We can send message to the agent, in this case, GenServer, to make some stuff. Okay, and let's go again to the great Visual Studio Code and see some examples of how we can work with GenServer. So here the task we don't need anymore, and let's see the GenServer. So again, we have a module that will be a wrapper around the state. So in this GenServer, we want to make the same as we made before in the agent. We need a process, we need a place in order to store all the currencies that will be available in our application. So we use the use GenServer because we are injecting the behavior of a GenServer in our module. So we have all the callbacks of our GenServer available to use in our module. So we have again the start lake. This is a function in order to spawn a new project. In this case, the GenServer will start with an empty state. So here we are providing an empty list. Then we have the init function. The init function is a function that we can use to return another state. In this case, it's an empty list, but if we want to make some other test, we can do that here. And then we have two public functions. In this case, we have the add element, the same as the agent. This is to store or add a new element. And the idea is that within this function, we are going to call the GenServer.cast. And we have the get element, and this is for getting all the available currencies. In other words, to retrieve the state. Okay, so here we have two public functions that inside of the function we are interacting with the GenServer. In this case, we have the handle cast and the handle call. So every time we want to add a new element in our GenServer, we are gonna call in the handle cast. The handle cast is a synchronous function, a non-blocking function, and then we have the handle call to grab the element from the state, and this is a blocking operation. So let's see some situations that we can have available in our GenServer. So let's say that I will add a heavy operation in my handle cast, and let's add this GenServer under our supervisor, and let's give it a try. So let's see what happens if we want to retrieve the state of GenServer. We have a heavy operation in the handle cast. Okay, so we go here and we call the get element, and the get element we execute the handle call. But let's first execute the handle cast, the one that has a heavy operation inside. So I will add a new element. I will add the Canadian currency, and we can see that despite the fact we have a heavy operation in the handle cast, the client is not being blocked because the handle cast is asynchronous. Let's see what's happened on the other hand if we put a heavy operation on the handle call. In this case, we are gonna execute the operation, the one that add a new element in the server. So here, let's happen when we execute the get element. In this case, the client is being blocked. And why is being blocked? Because the handle call is a blocking operation. So if we put too much logic or logic that takes too much time in the handle call, the client will be blocked. So that is something that we need to avoid or we need to take into account when we work with the handle call. Another small example that I want to show is that we mentioned before that the handle cast is asynchronous, so the client is not blocked. But what happens if we call the handle cast? The handle cast has a heavy operation, and right after we call the handle call. So we recompile the module. So we are gonna first execute the add element, and right after we are gonna execute the get element. So let's see what happens. So I wanna add a new currency and we execute the handle call. But what's happening here? Because the heavy operation is no longer in the handle call. What is happening here is that the client is being blocked despite the fact that the handle cast is asynchronous, because the handle cast is asynchronous from the client's perspective, but not from the server's perspective. So the client will not be blocked, but the GenServer will be continue executing that heavy operation. If we remember the slides of the processes are mailboxes under the hood, and here what is happening is that the GenServer is continue executing that heavy operation, so the next call, if the GenServer is still working, it will be blocked because every process can attend only one request at a time. So we also need to understand very well how work handle cast or handle call, because otherwise we can have uh, a program that is not working as expected. So let's keep that in mind. I'm gonna give one more example. Remember that in the GenServer, in the agent, we see that if we add a heavy operation in the initial state, in Sterling, the client is blocked. And in that moment, we mentioned that a possible workaround was to add a task to make that heavy operation. And after the task finish, we can backfill the agent with the state. Well, here in GenServer, we have another, let's say fancier way to deal with post operation logic. And for that, I have this GenServer. It's exactly the same as the other, but the difference is that in the init function, we are returning a tuple with the continue and a function name. So what we are doing here is that right after the creation of the agent, we are saying that we want to continue with the execution. We want to execute another function right after the initialization of the process. What we can achieve with this, or the idea for this, is that we can make post initialization logic with the GenServer, but without blocking the client. So that is a way that we have in GenServer to avoid blocking the client. So let's try to give this a try. So we are going to have the agent and this new GenServer with the post initialization. Um, what we are going to see is that after the startup of the GenServer, this will execute the continue. And in order to make an implementation for that continue, here is a new handle, a new callback. This is called the handle continue. This is expected to provide the function name in order to call and the state. Okay, so if we give this a try, we can see that in the output, we can see that the handle continue is being executed, but the client is not blocked because we delegate that heavy logic or heavy operation in the handle continue. This is a way that we have in a GenServer to make some post initialization logic, but without getting blocked the GenServer. Um, but let's say that our GenServer is so complex, and we don't wanna delegate the effort in only one function. Let's say that we wanna choose step because our GenServer is very complex, and we have another possibility in a GenServer. So in this handle continue, instead of returning the state, we can call another handle continue. Okay, so instead of returning this tuple, what we are going to do here is um, execute another continue. In this case, for example, we can call read file from disk. Okay, but obviously we need to implement that handle continue, otherwise we are gonna see some issues. So right here, what we are gonna do is implement that handle continue. Okay, so if we recall this, the GenServer will be starting right after the initialization. We are going to execute this make API call. This make API call is saying, okay, but we need one more step, so we need to continue with the implementation, with the flow. So here we are going to execute this read file from disk. Okay, so if we get this a run, read file from this. Okay, let's do the following. So we are gonna execute this. Here we have the handle continue. And yeah, let me check. This is a handle continue for make the API call. So here what we are doing is read a file from this. In this case, we are making a head operation, and we are returning that new state. And in the init, we are making the API call. Okay, and let's see what's happening here. Make a call. Well, probably there's an error on some of the returns of the function, but long story short, this is the idea. So if we want to split the return of the GenServer in most steps, we can execute the handle continue, but in some situations, if we can't, let's say, delegate all the functionality in only one function, we can add more and more and more layers. But we need to take into account that the more layers is the more work that the GenServer will wanna do. And yeah, that's it. A possible solution, a possible workaround that we have for our post initialization logic. So in summary, when working with Asent, let's try to avoid too much logic, and the same applies with the GenServer. We can't put too much logic, otherwise the client will be blocked, and client block is something that we don't want in our programs. And yeah, that is it. So the idea for me was try to show those three OTP features, and hopefully you enjoy our code.
Thank you very much, Alvaro. As promised, there might be some questions, and we have around a couple of minutes to answer them. So maybe I will pin the first question. Just a moment. All right, so this is the first one.
Okay, should we annotate a callback function, for example, with implementation equal true in a model implemented a behavior callback? If no, I just wonder how we guess that this function is a callback function defined in some behavior model. Are there any conventions to follow in this case? Okay, I think in terms of GenServer, it is not a normal convention. I know that, for example, you can annotate with add implement and making reference to which module you are making the implementation. But I think that providing the add implementation true in a module implementing a behavior is fine. I guess I've seen that in some projects. So yeah, I think uh, it will be a possible solution to just annotate with add implementation true. Okay, when a server could be a bottleneck, and what options are available to deal with it? Okay, so I would say that first of all, if we detect that a server has a bottleneck, the first that we can do is try to debug and find out the problem. Try to find a solution for that bottleneck. For example, if you, well, we see some example in which you have too much logic inside the GenServer. So maybe a good approach in order to avoid that bottleneck is to put aside that logic from a GenServer. Let's say to run a task, make that heavy operation with the task, and then send the result to the GenServer. So in that way, you can avoid that bottleneck of the GenServer. But again, probably the best solution is try to see what is the GenServer, because what is the bottleneck, because the result of that is the possible solution. So it depends on the bottleneck also. Do you use Umbrella project in general when making a new Elixir app? Well, to be honest, I never used Umbrella before. I know that Umbrella is a way that we have to organize application inside Elixir, but yeah, to be honest, I never used Umbrella before. I haven't used OTP features before, so this is a very interesting topic for me. When you were talking about task, I was wondering if task would be useful for something like an image uploader, where user can upload several images at once, and all of those images have to transfer in some way, result of something which takes some time. Yeah, I think that task can be a good use case about transforming data. In this case, the example that you are giving of you want to transfer image in some way, I think that yeah, task can be a good fit for that. In task, in fact, I think that tasks in general are very useful when we wanna make some specific work, but in an isolated way, because we send some example that, for example, GenServer and Asent enable us to send message, but task by default you can't send a message to a task. So I think that that kind of operation, that kind of heavy task, are a very use case to use a task. So yeah, definitely an uploader image at once or in batch, a task can be a very good example. Can the Shen server make a callback to a function that delegate a job to it? So what we are trying to do is to the function that delegate. Well, I think that what you can do is when you work with behavior is using the def delegate. The def delegate is a function or a feature in which you can delegate the implementation of a module into another module. So I guess that you combine a server and make a callback to the function. Yes, I think that it can be a good use case. I don't think I ever used that before, but yeah, definitely is something that you can do with Ashen Server.
Okay, that would be it. The last question. Thank you very much, Alvaro, once again. Alvaro presentation and today's talk will be available on our YouTube channel after a few days. And thank you for very fast answers on this Q&A. So once again, thank you for being part of this today's meetup. And we'll move on to Sigu, who will tell you a little bit more about GenServers.
Thank you. It just was a pleasure.
Thanks.